Let's start with the implementation of PageRank using points distribution method as we discussed in the previous video. I have pasted the 5 steps from the previous video over here, and we will take these steps one by one. So let me create a main function here. Okay, so let me import Network-X first of all. So let's take these steps one by one. So the first step is create or take a directed graph with n nodes. As I told you previously, we can use a generator for creating a directed graph. That is some function from Network-X we can make use of. For example, we have a function GNR graph which gives us a directed graph. We can use any function, or we can create our own function to create a directed graph as well. In this video we are going to create a directed graph ourselves, so let's see how we can do that. So as a first step, I'm just creating an empty directed graph by using this function g is equal to nx dot digraph. Okay, this graph is empty, but it is a directed graph. Now let's add the nodes and then we'll add the edges. Let's add some nodes to it. So I'll write g dot add nodes from. So we'll add a list. I'll write I for I in range. Let me add some 10 nodes here. We can add more as well, but I want to show you the conversions. If you take a number of nodes, if you take more nodes, it will take more time for conversions. You can always change that. So I'm taking 10 nodes at this point. Now we have added the nodes. We have to now add the edges. So I'm going to use a technique. Of course, you can use many different methods to create a graph. The method that I'm going to use here is that I will be randomly adding edges between the nodes. That is also a well-known technique to create a random graph, which I think we'll be discussing in the next week's videos. But I will be just briefing out the technique here because we will be creating this directed graph using that technique. So for that purpose, I will be creating a function. Let me create a function add edges. Okay, I'll pass the graph here which has nodes and no edges as of now. So I will be probabilistically adding the edges. I will briefly explain you the method as well. I'm passing a probability value of 0.3 here. Okay, and this function will be returning graph where the edges have been added. So let me create this function here. I'll create it here. So I'll write, okay. So as a parameter, this function requires a value of p, which is a probability value. So let me tell you what we are going to do here. So we're going to take all possible edges that can ever be added to the graph, and we will and we will add these edges to the graph after tossing a coin. By that, what I mean is, we'll take an edge and we'll toss a coin. If the coin turns out to be head, we will add that edge, and if the coin turns out to be tail, we will not add that edge. So here in this case, as you can see that we are passing a probability value p here, and the value of p we have passed as 0.3. You can pass any value here. You can pass any value between 0 to 1 over here. So by passing this probability value, what we mean is that you can assume that the coin is biased by a probability 0.3, which means with the probability 0.3 the coin will turn out to be head, and with the probability 0.7 the coin will turn out to be a tail. So we'll take an edge, we'll toss the coin which is biased by this probability value, and if the coin turns out to be head, we will add that edge, otherwise we will not add that edge. So this is the technique that we are going to follow. This is a well-known technique which is used to basically create random graphs. We are using this technique. You can use any other technique as well. So let's see how we can implement this. So we have to take all possible edges. How can we do that? I can start a loop. I can write for I in g dot nodes. So I got all the nodes here. because we want the edges. I'll start another loop here. So I'll write for j in g dot nodes. Okay, so I comma j will give us all possible edges. We are not going to add self edges, so I am going to check over here whether I is equal to j or not. So I'll write if I is not equal to j, only then go ahead. So we have to implement that coin tossing here. Now can you imagine how we can do that? We are going to take a random value. For that we need a random package, so let me import that. Import random. So we're going to make use of function random.random, which gives us a random value between 0 and 1. Let me store that here. R is equal to random.random. Okay, now we got some value here in R. We'll check whether that value R is less than equal to this p value or not. If R is less than equal to p, that means we got a head, and if R is greater than equal to p, that means we got a tail. So that's how we're going to implement that coin tossing part. So we got this random value. Let's check whether R is less than equal to p. If it is, we are going to add that edge. So I'll write g dot add edge. The edge is going to be I comma j, right? And in the else part, when R is greater than p, we assume that that's a tail, so we will not add that edge. We'll just continue here. Okay, so this is how we're going to add the edges. Now you know that this G is a directed graph, so the edges that are going to be added here by using this add edge function are going to be directed edges. Okay, so after this loop we would have added a number of edges, then we can return this graph. So this is our add edge function, and now we have created this graph G, and we can go ahead. So we are done with the first point. Let's implement the second one. It says assign 100 points to each node. So we have to maintain a list points which will be storing the points for every node, and we have to initialize this points list to 100. Let me create a function, although you can directly write it, but I am going to create a function for this. So I'll write points is equal to initialize points, and I'll pass the graph here. Okay, so let me create this function. Okay, so this function is just going to create a list points, and that points list will be having 100 points for each node. So I'll write 100 for I in range. What is going to be the size of this list? The size of this list is going to be equal to the number of nodes that are there in the graph, although we know that there are 10 nodes as of now, but we can always change that. So let me generalize it by writing g dot number of nodes. Okay, and then we should return this list points. Okay, we are done. Okay, let's go here. We have done the second point, so every node has 100 points right now. Let's go to third step. Third step says keep distributing points until convergence. Now how do we distribute points? Let's see how do we do that. For that purpose, let me create a function distribute points. Okay, so I'll write define distribute points. So this is going to be one iteration, and we are going to distribute points in this function. As you know that after the nodes distribute their points change. So we are going to need previous points and new points. Let us pass the graph here because we are going to need that, and let's pass the points that are there as of now. As I told you, previous points and new points. Let me create two lists here. So I'll write previous points to be the same as points, and this is just for ease of understanding. Another list I'll create new points. This is what we will be returning. So this list I'm going to initialize to 0, and during the distribution part this list will get more points, and that's what we will return. So for now I'll write 0 for I in range. g dot number, I would have copied, okay, g dot number of nodes. Okay, so this is the initialization of the new points list, which will be returned by this function. Now how do we distribute? As I told you, for every node we will look at its outlinks. So let me start a loop at this point. I'll write for I in g dot nodes. Now I is a node and we have to distribute its points. How do we distribute? We look at its outlinks, right? So let's keep a track of the outlinks of this node I. The function that we can use from networkx for this purpose is out edges. So I'll call that function. I'll write g dot out edges. Now this function is there for directed graphs only. The parameter will be the node. So we write g dot out edges. What this function does is, for the node I, it will return a list of the edges, which are out edges from this node I. Now after this node I has to distribute its points, an equal share of its points to its neighbors, right? So we have the points that this node I has in this list previous points, right? We are going to distribute these points equally amongst its neighbors, and the number of neighbors we can get by getting the list by getting the length of this list. Now what happens, what will happen if the list is empty? That is, the node has no outlink. In that case, the length of this list will be 0. So it's a good idea to check for that condition over here. So let me check if the length of this out is 0 or not, because in that case division by 0 exception might come. So it's better to check it here. So I'll write if length of out is equal to 0, which means this node has no outlink. Okay, if a node has no outlink, what should happen? It will not be distributing any of its points, right? So what we will write is new points for I are going to be plus equal to, I'll tell you why I've written plus equal to, previous points I. Okay, so I've written plus equal to because this point is going to retain its points. It's not going to give its points to anybody because there is no outlink. However, it might have some inlinks, and through those inlinks it might be getting more points. So that's why we have to keep adding it. So we have to write plus equal to. Now this is what we will do in case a node has no outlink. In the general case, that is, the nodes have outlinks, what are we going to do? We are going to distribute an equal share of this node's points to its neighbors. Now what is that share going to be? Let's create a variable share. Now the share is going to be the number of points that are going to be distributed to every neighbor. What is this share going to be? So as I told you, if there are 3 neighbors, the points that are going to be distributed is total divided by 3. Okay, and what is the number of neighbors here? The number of neighbors is equal to the length of out here, right? So what are we going to do is, we'll write previous points. That's what is to be distributed, right? You remember that you have to only distribute the previous points. So previous points are to be distributed in equal share. So we'll divide by length of out. So this is what is to be distributed. Let me do the float casting here so that we get the exact values. Okay, so this is the share that has to be distributed to the neighbors. Now where are the neighbors? The neighbors are in this list. This list is a list of edges. So for every edge, 0th value is the source, that is our node I, and first value, that is the value at index 1, is going to be the neighbor. Okay, so let us start a loop here in order to distribute the points. So I'll write for each in out, which means for every neighbor. We are going to update the new points of every neighbor. So I'll write new points for each. Now each is an edge, so I'll write each one. Each one is going to be the neighbor. Okay, so new points plus equal to share. So that's how we will be updating the points of every neighbor. I think we're done. Let us return. what are we going to return? We are going to return the graph G, and we are going to return the list new points. Okay, so we have created this function distribute points, which is going to be one iteration where every node will be distributing its points. Let's go back to main and let's see what we had to do. We have to keep distributing the points until the convergence. So we have to basically keep calling this function distribute points. So what we can do is, let me create another function which will keep calling this function that we have just created. Let's call this function keep distributing points, and the parameter will be G and the points that we have, and this function should return G and points again. So we are passing something and that is getting updated, and that's what will be returned. Now what should this function do? Keep distributing points. This function has to keep calling the function distribute points until we get the convergence. Okay, so let's create this function. Okay, so as I told you, this function has to keep calling this distribute points function. Let me start a while loop here. So what I can write is while 1. This should keep going on. Okay, what should keep going on? Before that, let me rename this previous points is equal to points. This is for the ease of variable names, that's all. Okay, so we are going to start this loop. This will keep going on and on. We have to call the function this distribute points, so I'll copy it and I'll call it here. This function returns two things again, so I'll write G new points is equal to this, right? What are we passing? We are passing previous points, so let me rename this previous points. Done. So we have called this function and one iteration has happened, and we have gotten the new points in this list new points. If we want to keep track, let's print this so that we can see the updated points. Okay, now this will keep going on and on. It has to stop somewhere, basically when the convergence happens. So you can do one thing, you can do one of the two things. You can either through your code check whether the convergence has happened or not. That is one thing. Another simple thing that we can do is we can keep observing as we are printing it, right? So we can keep observing these points, and whenever we see that convergence has happened, we can stop it. So for that, let us ask the user to stop it. Enter maybe hash to stop. Okay, and let's ask the user to enter a hash when he wants it to stop. So we'll take that through the function maybe raw input, and okay, if that char is equal to hash, we are going to stop. So I'll write break. Okay, now after one iteration we have to assign the new points to be the previous points, and we have to repeat the process. So it's important to write previous points is equal to new points. Okay, and after that we'll go back here and the same thing will start. All right, I think we're done. Let's return the same two things, G and new points. I think this function should work. Okay, we can maybe check the code as well if it is working fine. Wait, there's an error here. Okay, so let's check the functionality of this code, whether it is working fine or not. So let me call main here. Okay, let's get back to our screen and let's try calling this file. Okay, so these are the points. We did not print the initial points, right? They were obviously 100 each. We can print that as well. So these are the values that we are getting after one iteration, and we have to press enter after it. After I press enter, the next iteration starts, and as you can see, the points are changing. The first node was earlier having 33 points and now it is having 38 points. I am keeping on pressing enter and we are seeing the points how they are changing. So I keep on pressing the enter. Okay, as you can see, we are sort of reaching the conversions. So it may stop, it may happen that as you keep pressing enter it won't change at all, so nothing will change, or it may happen that values are changing by very nominal decimal points, so you can stop wherever you want, and or you can go on and on, so it's up to you. So I'm keeping on pressing enter and I can see the values changing slightly only by decimal points, so I can keep going on and on, or I can stop. So I want to stop, let me press hash and we are stopping. So these are the points distribution that we are getting, and we are sort of seeing the convergence taking place as well. Now let's get back to our code and let's see what is pending. Okay, next step is to get the nodes ranking as per the points accumulated. So we have to basically rank the nodes based on the points that they have acquired over time after a number of iterations after the convergence point. So I think we will do that in the next video.